Hi, my name is Bob Lambourne. I'm a physicist from the United Kingdom, and I work in a large distance teaching university called the Open University. And I'm here visiting Canterbury on what's called the Erskine Visiting Fellowship Programme, which is, as far as I'm concerned, a great programme. Firstly because, of course, it gives me the opportunity to visit this wonderful university, but also because I think it infuses all kinds of new lecturers, new views, new attitudes and so on into the University of Canterbury as well. So I like to think that just as I'm gaining from the programme, Canterbury will gain from my presence here. I'm interested in a very wide range of issues in physics. I'm also interested in things like the history of physics, the way physics works, indeed the whole shooting match really. I find it such a fascinating subject with so many different aspects. Over the years I've taught many different parts of physics, and I've gradually come to focus my own attention on the way the education system works and on how to improve learning in universities. While doing that, of course, I've got the excuse to go on teaching a wide range of subjects. So my teaching interests range from the very, very small, from elementary particle physics, all the way through astronomy, cosmology, up to the very largest scale things. Just earlier today I was talking to a class about the current nature of the universe and the curvature of space and time on the very largest cosmic scales. And I just think that's a wonderful mix of things to be able to do. Physics I find deeply fascinating. Of course, there are many different ways of trying to gain knowledge about the world in which we live and our own nature as human beings. But I've always found physics to be one of the most satisfying approaches, because I feel that I'm operating from a bedrock of sound knowledge. Because physics is based on observations of the world, although there are all sorts of interesting ideas and theories floating around, always in physics we come back to the constraint of observation of the real world. And not just observation, but very precise observation. That, backed up by mathematically based theorising, seems to me to give the thinking that we do as physicists, astronomers, cosmologists, that whole set of physical science subjects, seems to give that kind of thinking a kind of coherence and a kind of stability and reliability that is not always present in other parts of the quest for knowledge. And so, although I'm generally interested in a wide range of things, always when I search inside of myself for which part of knowledge do I most care about, it tends to be that which has been gained from the physical sciences and from the certainties that they can provide. I started my studies, at least university level studies, in the University of London. I took a physics degree and I was very lucky. I had some very good teachers. From there I went on to a PhD in theoretical physics, specialising on the internal composition of protons and elementary particle theory as described by quantum physics. And then I got in my first teaching job, which was in a maths department at the University of Durham, where I taught undergraduate classes on a few subjects including general relativity and cosmology. And since that time I've tried to mix the whole range of physics that I'm interested in, from the small to the large, and at the same time to keep up my learning in mathematics so that I have a relatively broad spectrum. On that basis, having taught many things, having become interested in the science of teaching itself, I've become involved in a number of international movements to try to improve teaching in universities. And it was really that work which led me to the current position I'm in, that of a visiting Erskine Fellow here at the University of Canterbury. So I'm doing some teaching here, certainly, but I'm also hopefully going to be investigating the teaching that goes on in the university and make my own small contribution to improving it. One of the things I really love about physics is its enormous breadth of application and the way in which one can use even the most ordinary objects to explain things. For example, here's a pair of scissors that I have on my desk. With these scissors, for instance, I could demonstrate the way in which a thing like a pulsar works. A pulsar is a very dense star that rotates rapidly, giving off radio waves, often compared with the lighthouse. Well, you can imagine if this was the axis of rotation of a pulsar, that this horizontal bar would be like a beam. But you can also see it raises then interesting issues like, could I put the beam at an angle? Could the radio waves from the pulsar be coming up at an angle like this and sweeping around the sky? And you can think about that quite deeply, working out how it would appear from various directions and what the probability would be of seeing a pulsar in radio emissions from different directions if this is how pulsars worked, or even if many pulsars worked like this. So even ordinary objects can help inspire good ideas about the way in which physics and the physical universe operates.
This is a little model of the James Clerk Maxwell telescope, which is a telescope I used to use a lot for my PhD, which sits on top of an extinct volcano at 14,000 feet in Hawaii called Mauna Kea.